article in English. English is not my first language, so this is a new experience for me. I have recently graduated from my neuroscience master's program, and I want to publish an article with my laboratory, and I've been struggling with it. So I decided it would be really cool to draw a mind map exploring what I have researched, what I have found during that research. And I think it could be a really meditative experience. So I could as well do an ASMR video with it. Also, my research was inside sleep science field, and I think that is the perfect topic for ASMR, and you might be curious about our findings. So let's try and do that, and I hope you will enjoy. By the way, I want to say sorry for the inconsistency with my channel, but this is just my hobby, and I hate the thought of making content just for the content. I really want to have fun and create something for you guys when I feel like it, and I have energy in me. Any scientific article has several parts in it. There is introduction, methods, results, discussion, and the conclusion. However, for this mind map, I don't want to create such a structure. I want to explore my results more freely, I think, to just get the idea of what we wanted to find, what was the hypothesis, what we did to find it, what results we had. So, I guess in the center, first of all, I could write the topic of the research and also the goal, the hypothesis. A beautiful pen. Okay, so the goal of my research, if I say it like in an abstract way, it was to learn the role of sleep in memory. It is a very broad topic, and there are tons of articles already about that, but that's where we can start. I will just trace the letters to make it more visible, because this is the central element and I want it to be really bold and noticeable. I'm not sure this mind map will be beautiful or anything, but I really think it might help me clear my mind and just understand my research better. So, in fact, as I mentioned, there are so many articles about the role of sleep in memory. Many scientists believe that sleep is essential for memory processes, for so-called memory consolidation, which means simply the formation of long-term memory. It is a type of memory that we are used to when we talk about it. Because for the short-term memory, you might forget this information 5 minutes later, or even a few seconds later. So it's just something more similar to attention. You just keep something in mind for the immediate result. So actually the term for this type that I'm describing is working memory. It's the information that you literally keep in mind for a specific task that you are performing right now. And it is just one of the types of short-term memory. Because sometimes short-term memory can become the long-term memory through the process of consolidation, and sometimes it will just vanish and you will not remember this at all ever again. So, as I mentioned, many people believe that sleep, full night sleep especially, is really important for memory consolidation. So, I kind of believe that as well, and I wanted to explore whether it is like that. So, what types of memory we tried to study? First of all, the declarative memory. Declarative memory is the most common and wide known memory. It includes your biographical memory, things that you know happened to you during your life. And it also contains facts, knowledge about the world, something you learned in school, for example, your beliefs and knowledge. Scientists also include spatial memory, so your inner map in declarative memory. This is just all sorts of things. As you can see, it contains all sorts of things. So it's really the most important, probably, type of memory for humans. And the most interesting. So in our experiment, we actually tried to test two types of declarative memory: verbal and non-verbal. For the verbal, we used the test where our participants had to memorize pairs of words, like in flashcards technique. We give them one word out of pair, and they have to remember or give the answer of the second word in pair. Students like to use flashcards for memorizing material for school subjects, for example, or when learning languages. On one side there is a word, for example, in English, and the other side contains the translation to another language. So you have to memorize them as a pair. In our case, we used pairs that were completely irrelevant and meaningless. So I will write word pairs. Meaningless. So there wasn't really a connection between two words in a pair, but participants still had to memorize them as a pair. And non-verbal memory was tested actually in memorizing pictures. Another difference between those two tests is that in case of word pairs, a participant had to actively extract the knowledge of the second word. So it's active memory. And in case of pictures, they just had to say if they saw this picture before or not. So it is simply recognition or passive memory. So you see there are two different classifications, verbal and non-verbal, but also active and passive declarative memory. And this is just one type. By the way, there is a thunder and rain outside of my window. And actually the window is open because it is very hot during summer. But I hope you don't mind. I personally find it even more relaxing when it rains. So, another type that we tested. Oh, I hope it will write. Yes. Okay. Now the blue pen. The second type is procedural memory. Let me write that down. Procedural, which is kind of a synonym of motor memory, motor skill. And the test we used is called tapping, which simply means that people were tapping on the keyboard of the computer. They had to memorize a motor sequence and then remember it, recall it in the morning. Yeah, I think I didn't mention the purpose of all this. Of course, they were firstly memorizing information, then they slept a whole night in the laboratory while I or other scientists were monitoring their sleep. And then in the morning after the sleep, they had to test how they remember this information or a motor skill, for example. I will write down motor sequence. So another type of memory that we tested was actually working memory. And it is interesting because, as I mentioned before, working memory is a special kind of memory because it doesn't include memory consolidation in itself. It is a short-term kind of memory. So we actually included it in another category of processes. So here, what was tested was consolidation. And we compared evening and morning. In the morning there was testing, and in the evening there was learning. I will also make it more bold. Consolidation. Consolidation, consolidation, consolidation. Consolidation. And another category of processes included working memory and attention, or vigilance to be more precise. Working memory and vigilance, let's write that down here. I find it really relaxing to just, lay on the floor like that and think about nature, about scientific stuff, drawing something that comes out of my mind. I hope you find it relaxing as well. It's definitely more of a lo-fi ASMR when it is not like super high quality or super refined, but more just chilling vibe, amateur vibe. And I think it also has a place on YouTube. So if somebody will like this, I'm glad. Okay, and the second one is vigilance. And they actually two of functions that are called executive functions in neurobiology or in psychology. So I will also write that down. And it's actually a really interesting thing. And I will explain why we even took those functions in our research just in a moment. Executive functions. Functions. Okay, so we wanted to compare those two categories, and there was a reason why we tried to compare them, or how they would change after a full night's sleep. So, as you already know, many people, many scientists study how memory consolidation proceeds during sleep. There studies. There are studies on humans and animals with brain slices, with single neurons, with electrical activity, and so on. So there is a certain consensus, I would say, that sleep is indeed important for memory. However, maybe this consensus is overrated, let's say, and my laboratory is quite skeptical about it. And not just because of wanting to be skeptical, but because in our laboratory for many years that the data was acquired, they didn't find a significant difference between results when people were deprived of certain sleep stages and when they slept normally. However, in other articles they did find the difference. So naturally they started to think, why is that? Why are our results so different from what is known in the literature? Of course, there is a certain problem in science that you might be aware of when the positive results are published and the negative results are not. So it might be misleading sometimes. But still, there are just too many articles that prove that memory is important. And it is indeed formed in sleep. So I wouldn't deny that completely. But it still leaves out the question why in our laboratory, even though we are very careful in our experiment design, if we work very hard to find the difference, we just don't find it. And in my particular work that I have done for the master's degree, I also didn't find any difference. And there were about 30 participants analyzed. So I'm a little bit going forward with this, but I just want to explain the idea. It is really basic, actually. So we didn't find that declarative or procedural memory consolidation change because of sleep deprivation. However, we did find difference in vigilance and working memory, which are executive functions. And executive functions are called like that because they are important for the basic functioning of the brain, especially vigilance, right? Vigilance is basically just being able to work, being in an active state, in an active wakefulness, So if we assume that our participants after sleep deprivation are just not vigilant enough, it would be natural for them to be bad at memory tests as well, just because they cannot concentrate enough, because their working memory is worse after sleep deprivation. And memory impairment would be just a side effect of that, and it wouldn't. So the result, the cause of memory impairment wouldn't be dysfunction of memory processes itself, but is that I only found statistically significant difference in executive functions, especially in working memory. But strangely enough, I didn't find any significant memory impairment at all when we talk about the consolidation. So that's a really curious topic. I will mark the working memory here just to say that it has statistically significant impairment. Okay. And I need to write somewhere that we actually did sleep deprivation of different sleep stages. More precisely, the third stage, or deep sleep, or slow wave sleep, and rapid eye movement sleep. Those were two stages that we deprived quite gently, actually, compared to another articles out there. So this was the main action that we did in our research. I think I will try to maybe even draw it somewhere to make it more easy to understand. Okay, let's now draw the basic scheme, I guess, the basic picture of the experiment itself, and then we will return to results once again, and I will try to discuss them, I guess. So, there are 3 main states before sleep, the sleep itself, and in the morning after sleep. So this will be a bed. Okay. This is a bed where a person slept. I feel like it is going to be looking ridiculous. No, I think it's more or less decent looking. Anyway, so here's the bed, which represents sleep, of course. Let's also draw a little blanket here. With little stars on it. You know, because people are sleeping at night and there are stars shining in the skies. Okay, so here's the bed, and it represents sleep. Of course, there is also a person in it, but I will not risk and draw a person, so it's just the bed. And here's before and after. And here are the tests. Okay, sorry. Okay, so the tests. And here's the learning. And tests. Why am I writing it like this? Because for executive functions there is no learning. You cannot learn to be vigilant or learn to have working memory, just have them. actually record how they are sleeping, and for that we're using polysomnography. Polysomnography includes EEG, electroencephalography, so it's the brain. I will attempt to draw a brain here, but I might not be very successful. I think, yeah, maybe something like that. Wow, I'm such a good neurobiologist. It looks more like a shell of a mollusk. Anyway, okay, so here's the cerebellum and the brainstem. Now it is a little bit better. Okay, anyway, here's the brain, EEG. It also includes electrocardiography. So, heart activity. It also includes electrooculography. So, eyes movement. And what else? There's also muscular activity. I will draw it like that. If you're a biologist, you will understand. It's how they are always drawn. Looks a little bit like a candy, actually. Okay, so why are we even recording all this? Well, first of all, just because we want to measure the quality of sleep with some objective method and not only subjective tests, which we also used. But also, why is that important? Because we performed another thing during sleep, and that is sleep deprivation that I already mentioned. Or we actually call it sleep suppression, because my supervisor says if we say deprivation, we imply that it was full. Like, for example, the person didn't sleep at all, or that the full stage, 100% of that stage was deprived. The analogy is when we say that, for example, an animal was deprived of food, it means it didn't eat at all. But we didn't do that. We only suppressed sleep stages partially to some extent. So it is not very harsh, and it is better to use the word suppression and not deprivation, even though deprivation is also technically correct, but is still less suitable. So I will draw it here in red because it's like the intervention, our intervention in participants' sleep. And I will write slow wave sleep and rapid eye movement sleep suppression. Like that. So there were 3 nights. They were not in the strict order, but I will just write them in numbers so it is easier to understand. So, for example, there is the first night with slow wave sleep suppression, the second night with the rapid eye movement suppression, and the third night, which is the control night without any suppression. So each participant actually slept in the laboratory 3 times. Well, to be more honest, not each participant did that. For some of them, there were only 2 nights. is slow wave suppression and the control night. But the whole concept was free nights, and there are just some exceptions to that. Okay, so this is the basic picture of what happened. We suppressed different stages, and we tried to understand, will it affect learning and executive functions. That's the idea. We also used this whole thing to monitor the sleep stages, because how would I suppress them if I don't know what stage is going on in a participant head right now, in their brain? So I would have to sit all night and look at their EEG activity mostly to identify different sleep stages. And when I saw, for example, that they are falling into slow wave sleep, and I need to suppress slow wave sleep that particular night, I would give them a sound. So the suppression was actually happening via sounds or tones. I will just write sounds because it's easier. And so I gave them sound tones in order to make them just fall out of the sleep stage and go into a lighter stage, like the first one or the second one. Because I think I will not draw it here, but I will just describe you that there are several sleep stages in human sleep. The first one is the most light, it's the lightest stage. It's very peripheral, and it is easy to wake up from this stage. Sometimes people don't even realize they are already sleeping because the conscious can still kind of be there. Then there's the second stage, then the third, which is the deep sleep or slow wave sleep, and the fourth stage is rapid eye movement. So yeah, something like that. And there is a massive body of research when people try to understand what sleep stage is related to what memory type or what function or what exactly is happening during each stage. So that's why we really wanted to separate them and not just deprive sleep chaotically, So it is suggested in literature that slow wave sleep is mostly connected to declarative memory, and the REM sleep is connected to everything else, like the procedural memory. And there are actually other types that I didn't write in here because we didn't research them in this particular study, but they are there, Like, for example, conditioning, like Pavlovian conditioning, it is also a type of memory that is suggested, to have a connection with RAM. There is implicit memory and all sorts of things. So basically, scientists, if they don't find that it is connected to slow wave sleep, they just assume it is connected with REM sleep. So yeah, to be honest with you, sleep science can be really chaotic and messy. That's why partially we took this topic, because we tried to introduce some more clarity into it and to challenge scientists, more professional scientists, they just sometimes get caught up in their topic and they stop seeing other data. They only want to see what is complementing their own theories. And sometimes it is fair, but in this particular topic it is not very good because it just doesn't allow to have a real consensus. There is so much chaotic data on that topic and it's hard to understand it because people, like big scientists, they tend to stuck in their own bubble and don't challenge their ideas so much. So in my study I really wanted to challenge the idea that sleep is even that important for memory consolidation, because in our experiments it turns out not to be so important, and those two particular stages, when we deprive them, it seems to not have any statistically significant effect, which is weird but also interesting. And that's why I want to publish, so that maybe somebody reads that and it's just a piece of, to think about. A thing to think about. So, okay, I wrote about the basic method. I wrote the basic background of this study. I think I can slowly go to results. Well, as I already wrote in here, only working memory has been statistically impaired, while all the other things weren't affected that much by our deprivation, which is weird. And well, I think we didn't have enough time to think about that because there was just little time for me to prepare the actual master's thesis and to prepare for the defense. But there are some thoughts that appeared after we got the results. Well, first of all, the main methodological result was that our suppression was successful, that our experimental paradigm worked, so it did suppress the stages. Otherwise, it just would be completely meaningless. If suppression wasn't successful, of course there wouldn't be any impairment, right? But in our case, that's not it. Our suppression was successful, but nevertheless, there was no memory consolidation impairment. The long-term declarative and procedural memory was successfully formed after the full night's sleep in the laboratory, whereas working memory has been impaired. And you might also be wondering what happened to vigilance, because I don't mention it as much. But that's because the result for vigilance was somewhat even more weird, I would say. Strangely enough, it didn't impair after slow wave sleep suppression, but it did impair after REM suppression. And what we actually, or maybe what my supervisor thinks about that, because she's more knowledgeable in this topic than I am, well, she says that after a good slow wave sleep, there is a big sleep inertia. After a good slow wave sleep, you are feeling sleepy. And I think many of you know this feeling when you wake up, but you don't feel like you are fully awakened yet. And that can last, well, for half an hour at least, but maybe it can even last for a few hours. And we were testing those functions within like 2 or 3 hours, maybe 1 hour. It's different for every test, but maybe sleep inertia was still very present after slow wave sleep, non-deprived slow wave sleep, and that's why vigilance was lowered in this case. But after deprived or suppressed slow wave sleep, even though it is bad for the brain, the sleep inertia or the sleepiness, saying more like generally, was a little bit increased, and that's why the vigilance has lowered. That's at least our hypothesis. The fact is that none of the consolidation was impaired after any of these suppression tests. Working memory was impaired after both of the suppression nights and was not impaired in the control night. And vigilance was only impaired after the REM suppression. Those are the basic results. Why were the results like that? To be completely honest, I don't know. Maybe I will find out what to write in the discussion part of this future article. I also want to just take a moment and read what I wrote in my actual master's thesis, because I don't fully remember. It was like 3 months ago. Okay, so what I was writing there, first of all, also I remember that I didn't write the names of tests for working memory and vigilance. Here it is called OneBack, and here it is called PVT, which is psychomotor vigilance test. And there were also like secondary tests. Sorry, their light just doesn't want to be there for us. Okay, so other tests that I didn't mention here, maybe I'll just write them in here in the corner. So there were sleepiness tests. There were 2 of them. Sleepiness. The Stanford test and the visual test, and both of them were subjective. There was also a test of quality of sleep, which was only in the morning, but I will still write it here just so it is in one place. Quality of sleep, and it was also subjective. And there was there are those additional tests, and there was no difference in sleepiness, in subjective sleepiness, but also there was some subjective difference It was also lowered in the control test, so not only after REM suppression but also after the control night without the suppression. So in both cases where slow wave sleep was intact, and only after slow wave sleep suppression was it changed. And that's why it's hard to interpret this test. Indeed. It is also interesting that after slow wave sleep suppression, procedural memory consolidation was a little bit more successful than in two other cases, which is weird. So I will just write it in small after, right here, after slow wave sleep suppression, like 2 arrows and 1 arrow after REM suppression and after control night, like no suppression. So it was, everywhere, and here it's also like the performance was better after sleep. I will just leave it like that, because like in all 3 cases maybe I'll write it like after 3, meaning that after all 3 nights it was better. And so, while trying to interpret those results, it all comes down to this sleep inertia. I think I will write it maybe in pink or in light green. I hope it works. It's a very weird pen to write in. No, I think it doesn't work. Let's use pink. So sleep, inertia, after intact slow wave sleep, like that. And the tests, they were the first test was performed about 1 hour after the awakening, because there was other stuff that we had to do before the actual cognitive testing. I can also write here the percentage of our suppression. So for the slow wave sleep it was 48%, and for the REM it was 51. So maybe this amount is simply enough for the memory consolidation to happen during sleep. And we also have to consider that memory consolidation also happens during wakefulness, which means consolidated, like for the most part, even before the person went to sleep. Somewhere in here, like after the learning and before they sleep, maybe that could happen. But it was, I think, physically impossible to put them to sleep just right after the testing. That would be really hard to do, in my opinion. And, well, by the way, our research is not the only one that demonstrates that the memory consolidation can successfully happen even after a significant sleep deprivation. There is a very cool scientist called Lisa Gansel in Netherlands, and one of her articles actually explores this idea that multiple night awakenings can just not lead to memory impairment. Well, I also think that the memory impairment effect can be recognizable if it is a chronic research. So maybe we would find a difference between two groups. If one group of participants was if we suppressed those sleep stages in them for a long time, not just one night, but at least a week, and then there would be a difference. Maybe, I think so. Because I refuse to believe that sleep is completely not helpful for the memory consolidation. That would be too extreme to say. But I guess what I'm trying to demonstrate with this study is that its role is maybe more subtle than many scientists try to portray. So, yeah, I guess that's the basic story, the basic narrative that's going on in this study, and what I want to tell in my article, my future very first English article in a scientific journal. Actually, I was published like a few times before, but it was honestly pathetic. They were like super, not even like low impact journals, but just almost non-existent to the scientific community journals. So publications in them, they don't mean anything, basically. And the studies in there, they were not so great, they were not big, So this is the first thing that I'm trying to do with like a real scientific study, with some really nice sample group, with a good methodology. I was working on this whole thing for 2 years. It was a very, solid amount of time. So yeah. Once we wrote down all of this, I think it is time to go into more details. For example, about the methods, maybe the introduction as well. But I think that maybe I will do it out of camera, because so we just could stop here for the moment. But if you are interested in this whole stuff, please write in the comments if I should make more videos about sleep science and memory science